Howdy, I'm Patricia Kio, and I'm in my 4th year of doctoral studies at the Department of Architecture in Texas A&M University. Circular economy seeks to reduce waste and turn them to valuable resources. We want to change the traditional way of taking, making, and disposing to a circular system. And by doing this, we use the 9 R's. They include the refuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, and recover. We use this to seek for harmony between economy, environment, and the society. Waste management and sustainability are relevant and connected to the circular economy. The renowned architect Buckminster Fuller, popularly known as Bucky, was the first to introduce a synergy. He wanted a network of world resources to form ecological systems so that there will be closed loops. Bucky was also interested in geometric experimentation, and he's known for the popular geodesic dome. This research proposes a framework for industrial symbiosis. Industrial symbiosis separates companies to share resources. Industrial symbiosis is used by companies to transition to a circular economy. This research will be carried out in 3 phases. The first phase will be a narrative review of sustainability reports from 15 automobile companies in the United States of America to find out their environmental indicators and metrics. The second phase of the research will be to characterize a circular economy case study. This case study is a living wall because living walls have been proven to have environmental benefits in urban areas. They cool walls for a maximum of 20 degrees Celsius. And this case study was installed on the southeast-facing wall of a building in the institution. Plant containers were made from metal scrap and used to fabricate the planters, also known as modules. General Motors supply these plant containers, and they support this, and they also fund part of the research. General Motors also provided data for the annual quantity of scrap metal, also giving us specific sizes of their geometry. This second part of the research will assess the external thermal properties of this living wall in its microclimates using 4 indicators. There will be the air temperature, the relative humidity, the wind speed, and the solar radiation. The third part of this research will be a combination of a cost-to-benefit ratio and the cost-benefit analysis to determine the triple bottom benefits. These are the environmental, the economic, and social impacts of using this living wall in the microclimates. There will be a quantitative assessment to determine the correlation between the material, the geometry of the modules and their thermal behavior. Also, we have a factor known as the material circularity determining factor to show how much waste can be avoided by design. The results of this study will be used by architects for industrial symbiosis. It will also be used by stakeholders to achieve their zero waste targets. It will also help them to set baselines and provide jobs through circular economy. Circular economy fosters environmental protection without limiting economic growth. Future studies for industrial symbiosis frameworks will be carried out between industrial sectors. 4 departments were involved in this research: the Department of Architecture, Landscape Architecture, Mechanical Engineering, and Supply Chain Management. I want to say thank you to my advisor, Dr. Ahmed K. Ali, and other members of my committee, Dr. Robert Brown, Dr. Balthazar, Dr. Layton, and Dr. Eleftherios Yakubu. Thank you.